Okay, finite people. Sorry I can't be there today. Taking my mom to the hospital again. Chapter 5 is all about things you already know. It's about equations of lines, intersections of lines, slopes of lines, that sort of stuff. General graphing that you did in Algebra 1, Algebra 2. So if we start off with ax plus by equals c, this is the standard form of the equation of the line. As long as x and y are to the first power, we have a linear equation. And it could be that maybe a or b could be 0, but not both at the same time, because then you end up with 0 equals c, which is either always true or never true. So you could have just by equals c or just ax equals c, and that's still a line. But nothing can be squared, neither the x nor the y. Okay. To graph a line like this, maybe 7x minus 3y equals 21, 2 points that are of some interest are the x and y intercepts. To find the x-intercept, you let y be 0. And that's because on the x-axis, the y-coordinate is 0 everywhere. So if you do that on this one, you get 7x minus 3 times 0 equals 21. 7x equals 21. X equals 3. As a point on the graph, that's the point 3, 0. Okay, to get the y-intercept, same deal. For the y-intercept, you let x equals 0. And again, the logic is that any point on the y-axis has an x-coordinate of 0. So if we do this, we're going to get that 7 times 0 minus 3 times y equals 21. Negative 3y is 21. Y equals negative 7. So the point 0, negative 7 is the y-intercept. Okay, well, let's suppose that the next thing says, well, we want to graph that. Okay, I'll just record a couple facts up here so I can erase. Here's our equation, and we have 2 points that we know, 3, 0, and 0, negative 7 are on our graph. Okay, so just a rough graph here, x and y. 1, 2, 3. Over here, the point 3, 0 is the x-intercept. 1, 2, 3, 4, 5, 6, 7. 0, negative 7 is the y-intercept. And 2 points make a line. Draw your line. Okay. Once we've done that, there's another thing that we're typically interested in, and that's the slope of the line, because it gives us the rate of change of one variable in terms of the other, typically y in terms of x. And slope, m for slope, is rise over run. So rise is the change in the y-coordinates between 2 points. So we can see that this rises 7 units for a run to the right of 3 units. So the slope here is 7 over 3. The rise over the run. Okay. Another way to get the slope is just from the slope formula. So if we have m for slope, the formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And these are where x1, y1 is 1 point and x2, y2 is the other. So suppose that we call this guy x1, y1 and call that guy x sub 2, y sub 2. Then the formula says that the slope is equal to y2, sorry, there's an error there, y2 minus y1, that would be negative 7 minus 0, divided by x2 minus x1, 0 minus 3. And what I'm going to get is negative 7 over negative 3 or a positive 7/3. Same result we get with rise over run. Okay, so that's basic graphing, equation in standard form, the concept of slope. Now the next thing that we've got then is there are other forms of the equation of lines that are sometimes more useful. The one that you're probably most familiar with is slope-intercept form. And if I lose my graph here, if I just take and solve this for the variable y, that would be negative 3y equals negative 7x plus 21. Now divide by negative 3, y equals 7/3 x, and that's minus 7. And this is in slope-intercept form. Slope-intercept form is the form y equals mx plus b. And in this guy, the m, the slope, we've seen 3 different ways of confirming that's 7/3. It's the coefficient of the x, and the y-intercept is the negative 7, which is exactly what we said earlier. The y-intercept was going to be negative 7. So if you already know, let's take this the other way. This one we did it the first time. We started off with the equation of the line, and we graphed it. Well, maybe we know some things about the graph. Maybe we know its slope because we knew there were 2 points on it, and we knew the y-intercept. We could go straight to this as being an equation of the line. Okay, and that's going to be a guy that's very convenient to work with. So that's slope-intercept form. Y equals mx plus b is slope-intercept form. Okay, the last form of the equation of the line is called point slope. And it's convenient, just as its name might sound like, because of when you have a point and a slope, and particularly if the point is not the y-intercept. If the point's the y-intercept, we'll go right here. Okay, let's suppose that we just want to find the equation of a line where we've got a slope and 2 points. Okay, first of all, here's our form. It is y minus y1 equals m times x minus x1. And that's called point slope form. And in this, m is the slope, as always. And x1 comma y1 is some point on the line. The word line doesn't quite make it on the screen there. It's point on line. Okay? So let's suppose, as an example, that we want to get the equation of the line, and it'll have a slope of 2/3, and a point on the line is 2, negative 1. So this 2, negative 1 is the x1, y1. So this is y minus y1. y1 is the negative 1. So minus a negative 1 is equal to the slope, 2/3, times x minus the x coordinate, which is 2. And we're done if the problem doesn't say put it in some other form. But if you wanted to get this into that, from there to slope-intercept, that would be y plus 1 is equal to 2/3 x minus 2/3 times 2 is 4/3. And now if I would subtract 1, my final answer is going to be that y equals 2/3 x minus 7/3. And that lets us know that on this particular problem, the point 0, negative 7/3 is the y-intercept. And that's everything that you really need to know to do anything in the first section, section 5.1. I guess as one last comment, parallel lines have the same slope. So if 2 lines are parallel, they have to have the same slope, and that's the other concept in the section.